Still on motion, question number 2. This question is UTME 1988. And the question is like this. An aeroplane lands on a runway at a speed of 180 km per hour and is brought to a stop uniformly in 30 seconds. What distance does it cover on the runway before coming to rest? Remember, I told you that the first thing you need to do in solving a question like this is to set out your parameters. Now, they said an aeroplane lands on a runway at a speed of 180 km per hour. This is my initial speed. This is my U. Because I said that is the velocity it is starting with. So, U is equal to 180 km per hour. If you observe this, there's a problem to this. Why is there a problem? Because your unit is kilometer per hour. The unit should be in the SI unit, which is meters per second. So you need to convert. An easy way to convert from 180 km per hour to meters per second is to divide your 180 km per hour by 3.6. So I'm going to divide this by 3.6 to convert it to what? Meters per second. So to convert from kilometer per hour to meters per second, you divide your kilometer per hour by 3.6. So I'll come here and say 108 divided by 3.6. If I divide 180 rather, not 108, 180 by 3.6, I'll get 50 meters per second. So the easy way of converting from kilometer per hour to meters per second, divide by 3.6. Here, they did not mention the acceleration or the deceleration, but obviously I know that this guy was decelerating because it was moving with the velocity before and then it came to rest. So it is decelerating, but they did not give us the value of the deceleration. They only told us that it decelerated to rest. If it decelerates to rest, then final velocity will be equal to 0. Because I told you initially that if a body was already moving and decelerates to rest or retards to rest, final velocity will be equal to 0. So here, V is equal to 0. They gave us time, and they told us that the time is 30 seconds. And we are being asked to find the distance it covers before coming to rest. So from these all parameters that have been given, which of the equation is best suited for this? It can't be equation 1, it can't be equation 2, and it can't be equation 3. Because none of those one from equation 1 to 3, deceleration or acceleration is there, A is there. But in this question, A was not given to us, so I cannot use any of those ones. What I will do is to use the last equation, the fourth equation. And the fourth equation is, let me wipe this part off. And the fourth equation is S is equals to, open a bracket, V plus U over 2C. This is the equation. Now, using this equation, I'm going to have S is equal to, final velocity is 0, initial velocity is 50. Note, like I said previously, it does not matter whether the body is accelerating or decelerating. I obviously know that this body is decelerating. But when using the fourth equation, it does not matter whether the body is accelerating or decelerating. We are always using plus for this fourth equation. I need to emphasize on that. So divide by 2, close the bracket. Our time is what? 30. If I work on this, I'm going to have S to be equal to 50 divided by 2 times 30. If I divide 50 by 2, I'll get 25 times 30. If you multiply 25 times 30, you should get 750 meters, which is option C. Now that is how to take the question. In our next class, we'll be looking at motion under gravity.